Section 5.5, Trigonometric Equations, Part 2 of the notes. Example 4, we're going to solve 2 cosine squared of x equals 4 cosine of x plus 6. This is again going to be a quadratic that we're going to need to factor. So the first thing you're going to do, I'm going to have you do this problem on your own, but let me just kind of talk you through it. The first thing you're going to do is move the 4 cosine of x and the 6 over to the left side so that everything is on the same side. And then you'll be able to divide out a common factor here of 2, and then you can factor what's left. So pause your video, try this one on your own, see what you can get, and then restart it to watch my answer. Okay, so again, we start by moving everything to the left side, dividing out a factor of 2. Now, since a is 1 here, we can actually kind of factor it in an easier way. We don't have to do factor by grouping. We can just go straight to our 2 factors. If you did use factor by grouping, you should still get the same thing as me. Okay, so now we're going to set them equal and solve. So first of all, cosine of x equals 3. Nowhere on the unit circle do we have an x value of positive 3. So that one we're not going to use. We're just going to cross that off. For our other answer, though, we do get x equals pi. Any answers we want on the interval of all real numbers, we're just going to add on 2n pi to our answer of pi. Example 6. We're going to solve sine of x tangent of x equals sine of x on the interval 0 to 2 pi. And we're going to do this by factoring out a greatest common factor. So our first step here is going to be to get sine of x on the other side of the equation. So we're going to subtract it over. And then we're going to pull out a common factor of sine of x. At this point, we can use the zero product property like we've been doing in previous examples. We'll set sine of x equal to 0 and tangent of x minus 1 equal to 0 and solve. So y is equal to 0 whenever we're at the radians 0 or pi, and tangent of x equals 1 at the radians pi over 4 and 5 pi over 4. Example 7, using an identity to solve a trig equation. For this problem, we're going to recall back to our double angle theorem. And at the end of the notes, I gave you 3 different forms of cosine. We're going to use the form 1 minus 2 sine squared of theta, because if I replace my cosine 2x with that portion of the identity, then I will have a sine squared and a sine in my equation, and I can factor at that point. So I'm replacing cosine 2 of x with 1 minus 2 sine squared of x. I'm rearranging my terms so that I can factor. Need to put this in standard form. Changing all of my signs so that my a value is positive. And then factoring. Next, I'll set each of my factors equal to 0 and solve. y is negative 1/2 at these 2 radians, and y is equal to 1 at pi over 2. For the next example, we're going to solve 2 cosine squared of x minus sine of x equals 1. So again, since I have a cosine squared and then just a sine term, I know I'm going to need to use some identity to replace cosine squared of x with something in terms of sine squared of x. So I'm using the Pythagorean identity. We know cosine squared of x plus sine squared of x equals 1. So I can rewrite that in terms of cosine squared of x, which I have here in red. I want you to try this one on your own. So pause your video, plug in 1 minus sine squared of x, simplify, factor, solve, restart the video to watch my answer. So I'm starting by plugging in 1 minus sine squared of x for cosine squared of x, distribute the 2, and then move things into standard form. And now I'm ready to factor. I'm using factoring by grouping because my a value is not 1. Set each factor equal to 0 and solve. Our next example, we're going to solve 4 cosine squared of x equals 5 minus 4 sine of x. Again, I see I have a cosine squared of x and a sine of x, so I'm going to use my Pythagorean identity to replace cosine squared of x. Again, I want you to pause the video, try this one on your own, and restart it to see my answer. After we factored, both of our factors were the same, so I just wrote that as 2 sine of x minus 1 squared. So when I set that equal to 0, I just have to set it equal to 0 once. I don't have to set it equal to 0 twice.